this video, we're going to look at finding the voltages and the currents in a combination circuit. In this circuit that I've done on a previous video, we've already determined that the total resistance of this entire circuit is 12.5 ohms. We're going to begin with finding the total current through the entire circuit. So for that, we're going to use Ohm's law. V equals IR. But just with the totals. So the total voltage is 25 ohms. Current we don't know, but the resistance is 12.5 ohms for the entire circuit. That means my total current leaving the battery is 2 amps. Now, at this point, we have to do what I call follow the magic finger around a little bit. So the current comes out, splits, and then comes back together. The current has to go through the 5 ohm resistor, so I automatically know that the total current going through that is 2 amps. As soon as I know that, I can figure out the potential drop or voltage drop across that resistor. So I'm going to use Ohm's law again. This time for just the numbers that apply to that resistor. It gets 2 amps of current. Its resistance is 5 ohms. So it gets a voltage of 10 volts. So of the 25 volts that come from the battery, this one uses 10 volts of it. Now what's left gets to the parallel part. So if there's 25 volts that comes from the battery, that one uses 10. The parallel section only gets 15 volts. And since it's in parallel, both sections get 15 volts. Now that I know what the voltage is for each one of those, I'm going to figure out how much current goes through each section. Again, I'm going to use Ohm's law, V equals IR, but just for those individual resistors. It gets 15 volts. The current we don't know, but the resistance of that first one is 12 ohms. So if I take 15 divided by 12, I get 1.25 amps. So there's 1.25 amps of current going through this resistor. To figure out the other one, I again use Ohm's law. To find this one, so we go 15 divided by 20, we get 0.75 amps. So this one gets 0.75 amps. Now here's a good place that we can check, because since the 2 amps of current through here split, well, the current in this section plus the current in this section should add up to 2 amps. If we take 1.25 plus 0.75, it does add up to 2 amps. So we didn't lose any current, which is good because we shouldn't. Now that we've got that, we can figure out the powers. So for each one of these, now we can figure out the powers. So for each one of these, we can first figure out the total power. Again, I'm going to use the totals because we'll figure out the total power of the entire circuit first. So the total power of my circuit is 50 watts. I don't know the powers of each individual thing, but we're going to figure that out now. Because since we already know the voltage drop and the current for each one, we can simply multiply them together to get the power of each resistor. So that one draws 20 watts of power. Now to find the power of the second one, P2 equals I2V2. So the current is 1.25 amps, and the voltage is 15 volts. So if we do that one, 1.25 times 15 gives me 18.75 watts of power for the second one. For the third one, same process. P3 equals I3 V3. Current is 0.75. And the voltage is again 15 volts. So 0.75 times 15 gives me a power of 11.25 watts. Now the neat thing about this one is if we add up all the powers, 11.25 plus the 18.75 plus the 20 watts, we would get 50 watts of power, which is the same as the total power, which means we should be fairly confident in our answer. Now for another slightly different circuit. Now this circuit, unlike the other one, doesn't have that convenient resistor in series that makes solving these problems a lot nicer. This one, we have 3 resistors, but the main line is in parallel, although we do have some in series inside one of the branches. So the first thing we need to do is figure out the total resistance of the circuit. Well, first I'm going to go ahead and combine these two and get the equivalent resistance of this. And because they're in series, we simply add up the resistors. So this segment has a total resistance of 25 ohms, but it's in parallel with this 12 ohm branch. And so we're going to use that to figure out the total resistance of the circuit. So 1 over RT equals 1 over 25 plus 1 over 12. When we do that, we get plus 25 inverse equals, we get 0.123 repeating. But that's not our total resistance. We have to take the inverse one more time, and we get a total resistance that I'm going to round off to 8.11 ohms. Now that we've got that, we're going to go ahead and figure out the total current in the circuit. And so to figure out the total current, we're just going to use V equals IR, Ohm's law. The voltage is 12 volts. The current is what we're looking for, and the resistance is 8.11 ohms. So divide, and we get 1.48 rounded. Now, when we had a series segment all by itself, we actually knew the current that went in there, but in this case, we have 2 parallel components, so that current is going to split when it gets to that parallel section. And right now, we don't know how much current goes which way. But the way we can solve that is, we do know both parallel components get the same voltage. And we do have one parallel part that's by itself. And so we know this segment and this segment both get 12 volts. But this one's by itself, so it gets all 12 volts. So we know R3's voltage is 12 volts. Now that we know that, we can actually figure out the current going through that segment by using Ohm's law. Voltage is 12. Current we don't know, but the resistance is 12. So that segment gets 1 amp of current. Well, we have a total current of 1.48. So if 1 amp goes through this segment, then 0.48 has to go through the upper section. So both these, since they're in series, get 0.48 amps. Now we can go back and use Ohm's law to figure out how much voltage each one of those gets in that line. So the first one, 0.48 times 5, gets 2.4 volts. So for this one, we get 0.48 times 20. So 0.48 times 20 gives me 9.6 volts. And as a quick check, if we take 9.6 volts and add it to the 2.4 volts, we get 12 volts, which is our voltage from the battery, and which is the voltage that line segment should get. Now, to figure out powers, it's just simply using the power equation, P equals IV. So, total power is total current times total voltage. So the total current was 1.48 amps, voltage was 12 volts, and so our total power becomes 17.76 watts. Now we do that same process with the individual resistors. Current 0.48, and the voltage drop for it is 2.4. 0.48 times 2.4 is 1.15 rounded watts of power. For the second one, same process. Voltage is 9.6. .48 times 9.6 gives a power of 4.61 rounded. And for the last one, same thing. Current is 1 amp. Voltage was 12 volts. So its power is 12 watts. And if we add those up, we got 12 plus 4.61 plus 1.15, we get 17.76 watts, just like our original power. So again, we should feel confident about our answer. Let's try a little bit more difficult problem and kind of mesh everything together. Okay, here's a much more complicated circuit. We've got 5 resistors, 2 sections that are in parallel, while 1 resistor is in series on the main line. And so we first need to figure out the total resistance of this entire circuit. So since we got 2 parallel sections, this one, we need to find the equivalent resistance of this part first. So 1 over RT equals 1 over 12 plus 1 over 36. Add the inverses. Take the inverse of that to get RT. So we get the 36 inverse plus 12 inverse. Then take the inverse of that to get a total resistance of 9 ohms for that first parallel section. Now this is in series, so it's just 2 ohms. Then we need to get the equivalent resistance of the second parallel section. So that will be 1 over 5 plus 1 over 20. Add those together, then invert the answer. So 5 inverse plus 20 inverse, it equals. Then invert that, we get an equivalent resistance of 4 ohms for that second parallel section. So that means our total resistance of the circuit is going to be 15 ohms. Now, just to make things simpler on everyone, I want to go ahead and change our voltage because I want to make it turn out to be a nice number. And so let's say, for our example here, that we have a voltage of, let's say, 45 volts. That'll make the math come out a lot easier on us. So now that I got the total resistance of 15 ohms, I want to figure out the total current by using Ohm's law. So our total current is 3 amps for the entire circuit. Now, obviously it won't be 3 amps everywhere because of the parallel sections, but where it is 3 amps is at this resistor right here, because it's in series with the main line. So even though the current splits, comes back together, all of it has to go through there before it splits again and comes back. And so we get a total current of 3 amps through resistor number 5. Now that we know that, we can figure out the voltage drop for that resistor. Three amps. Resistance is 2 ohms. So it has a voltage drop of 6 volts. That means that it uses up 6 volts of the 45 volts that comes from the battery. But we got 2 parallel sections. They don't necessarily get the same voltage. And so we have to figure out how much voltage each section gets. The way we're going to do that is with the total or equivalent resistance of that segment. So that top segment has an equivalent resistance of 9 ohms. So we're going to use that to figure out the voltage drop for that segment. So V equals IR. Voltage we don't know. The total current through there. All 3 amps have to go through there. So it gets 3 amps and its equivalent resistance was 9. So we do that. 3 times 9, 27. So it gets 27 volts. So that means R1 gets 27 volts and R2 gets 27 volts. Now, to kind of look and see how we're doing with this one, we're going to use Ohm's law again to figure out the current through each one of those resistors now that we know the voltage. So V equals IR. So voltage was 27. Current we don't know, but the resistance of that top resistor is 12 ohms. So 27 divided by 12 gives us 2.25 amps that go through that top resistor. We're going to do that again for the second one. $27 volts. We don't know the current, but the resistance is 36. We get 0.75 amps for that one. Now we can check our answer. If we take 0.75 plus 2.25, we get 3 amps like the total current should be. So we accounted for all the current in that parallel section. We're going to do the same process again for the other parallel section. So, using its total resistance or equivalent resistance, three amps total go through there. Its equivalent resistance was 4. So each one of these should share 12 volts. Now we can use that voltage to figure out the current in each part of it, just like what we did in the first segment. So 12 divided by 5, 2.4 amps for this one. Same process. Twelve divided by 20 this time. You get 0.6. And again, we can check our answer. 2.4 amps plus 0.6 amps is 3 amps. So again, we have accounted for all the current going through that parallel segment. And do the powers, same process as we've done before. Simply take the total current times the total voltage for each one. I'm going to go ahead and do that to make the video a little bit shorter, and then I'll get back to you with the answers. I've calculated all the powers. We take the total current times the total voltage. We get a total power of the circuit to be 135 watts. If we take the individual current times the individual voltage for each one, the power for the first one is 60.75 watts. Second one, 20.25 watts. Third, 28.8 watts. The fourth one, 7.2 watts. Then the last one, again, taking current times voltage, is 18 watts. Then we add up all the individual powers, again, we get the total power of the circuit. So everything works out. Thank you. Talk to you later. Bye.